Good afternoon, dear students. In this class, we are going to discuss about gypsum. It's one of the calcium compound. So, gypsum is an important compound, and I hope you all familiar with this name gypsum. Chemical formula of gypsum is CaSO4 2H2O. This is chemical formula of gypsum. Generally, this gypsum is occur from the mineral from the earth crust only. So because of some geographical reaction during the prehistorical time. So the geographical reactions like evaporation of water in the massive prehistoric sea basins. So when the sea basin, when the basin with the water, that water is evaporated from that land. So because of the evaporation of water molecules or only the vapor of that land, it is evaporated, and other all the minerals is present in the sea water that is deposited on that gypsum bed. So because of this evaporation of water, this gypsum bed become more concentrated mineral. So generally because of this water evaporation, this minerals in the land, it's become more concentrated, and it is a crystalline form. It is in the crystalline form. So we can see some properties of gypsum. Gypsum is a soft material. It is a soft material. Soft mineral, and it is moderately soluble in water. When we look at the solubility of gypsum in water, the character of the solubility of gypsum in water is retrograde solubility. Why it's called the gypsum solubility in water is called retrograde solubility? When compare this gypsum with the all the material, other minerals, they can if they increase the temperature of water dissolved in the material, they will because of increasing the temperature, they will dissolve into the water. But gypsum is different from that other minerals, because this gypsum is not dissolving in the water when increasing the temperature. So it can show only the less solubility with the increasing temperature. So that character is known as retrograde solubility. So that's this retrograde solubility character shown by gypsum. So this is a distinctive property from the other all the compounds. Generally, gypsum is in white color, colorless, and gray in color. But in sometimes they can found in the form of shades of pink, yellow in color, brown, and light green. So why it is exhibit or found in the shades of pink, yellow, brown, and light green? Because of the impurities is present. Impurities in gypsum. And we know that gypsum in the crystalline form, and some crystals of this gypsum can found in some areas like arid area and desert terrains. desert terrains, where it is found that crystals which is found from arid and desert terrains, mostly they are similar with the petals of a flower, okay, of a flower. So this the shape is resembles with the petals of flower. Because of this character, it is refer the name as desert rose. Desert rose. Why it's called as desert rose? Because it's found in the arid area and the desert terrain in the type of petals of a flower shape. So that's why it's called desert rose. So the name of that is desert rose. And using this gypsum as a natural insulator. Why? Because of the low thermal conductivity. Their low thermal conductivity. So because of this reason, we can make this with the help of gypsum. We can make dry walls or wall boards. Okay, and also using this gypsum as a natural insulators. Next character of this gypsum is the important one, alabaster. So remember this name, alabaster. So alabaster is a variety of gypsum. It is a type of gypsum, but it is a highly valued ornamental crystal or ornamental stone. It is a solid one, we know that. Alabaster is a type of crystals which is using in ornaments. Okay, so using in ornaments as a ornamental stone. So it is a high value crystal. Alabaster is a granular one and it is big, and because of this the high value ornamental alabaster used for the sculptures in the centuries before, we use this for sculptures. And their gypsum hardness is between the range 1.5 to 2 more hardness scale. So their hardness 1.5 to 2 ranges. Then its specific gravity 2.3 to 2.4. This is the range of specific gravity of gypsum, and this is the range of hardness of gypsum by Morse hardness scale. So we have learned the properties of gypsum. Now uses of gypsum. In properties, we learn alabaster is a variety of gypsum and use this as a sculpture in the centuries. So in Egypt and Mesopotamian civilization time, they used this alabaster for making the variety of sculptures, and the Egyptian they know that the ancient Egyptian know that to convert this gypsum into the plaster of Paris. This plaster of Paris also a calcium compound. This gypsum they turned the gypsum into the plaster of Paris about 5,000 years ago. So on that time they know that. So gypsum is used from the ancient time, but nowadays we use this gypsum for the variety of uses and variety of application. It has some variety of application. So first used this for sculptures in ancient time. Nowadays we are using this gypsum for making dry walls or plaster boards. For making dry walls and plaster boards and also for finishing the wall finishing and ceiling finishing, then for the partition finishing, everything we use the gypsum. Gypsum is mainly used, or the important use of the gypsum, to produce plaster of Paris. Preparation for plaster of Paris. Plaster of Paris. To convert this gypsum into the plaster of Paris, gypsum is heating above 300 degrees Celsius Fahrenheit. So to produce this, to convert this gypsum into the plaster of Paris, heating up to into the 300 degree Fahrenheit. So this process can produce the plaster of Paris, and that product is known as gypsum plaster. So mainly gypsum plaster using as a sculpting materials for the sculptures. Next important use of gypsum. Gypsum is using to make a surgical uh, cast and orthopedic cast, then also using for making or producing surgical splint and casting molds also. Okay, so for the medical field we use this surgical cast, orthopedic for the orthopedic cast, and also for surgical splints and casting molds. Gypsum also using in the agriculture department to fertilizing the soil and to additives and to adding there for the conditioner. For fertilizer, conditioner and additives. So this gypsum is using here to loose up the clay soils or the compact soil, and they provide here calcium and sulfur minerals to the soil. Sulfur to soil and also loosening up the soil. Loosening up the soil or the compact clay. So because of adding this calcium and sulfur into the soil, it is giving the more essential, it is a more essential mineral for the plant, and also it's using here to grow the healthy plants. Because of the addition of calcium and sulfur into the soil, they remove excess amount of sodium from the soil. That means the salinity of soil is removed because of adding this gypsum into the soil agriculture field. So removing salinity. Removing salinity. And also using this gypsum into toothpaste, shampoos and hair products, mainly for binding because of their binding and thickening properties. And also using this for Portland cement, for preparing the Portland cement. That means it is one of the component of Portland cement. And so because of adding this gypsum into the Portland cement, it is behaving as a hardening retarder. That means it's reduced the tendency of hardening of cement. Okay, so the speed of thickening property thickening of that cement or hardness of that cement, it's reducing because of adding gypsum into it. So generally gypsum is using many field and it is easy to mining. So it is a simple and easy process to mining from the earth crust. But because of the large scale of mining, it is damaging our environment, and we can recycle the gypsum, but not much because of the abundance amount of gypsum is present in our earth crust. The more recycling process is not happening. These are the uses and properties of gypsum. Next and the last important compound of calcium is plaster of Paris. So the chemical formula of plaster of Paris is CaSO4 H2O. So this is chemical formula of plaster of Paris. To preparing this plaster of Paris, gypsum is heating up to about 393 Kelvin. Up to 393 Kelvin. So the reaction for producing hemihydrate of calcium sulfate, that the chemical name of plaster of Paris is hemihydrate of calcium sulfate. Hemihydrate of calcium sulfate. So the chemical reaction for preparing this plaster of Paris from the gypsum is 2CaSO4, 2H2O. This is in solid because gypsum is a solid one, and it become CaSO4, H2O, 3H2. Okay. When increasing the temperature above 393 Kelvin, it lost all the water molecule from this plaster of Paris. So this crystal particle will left like anhydrous calcium sulfate. That means releases all the water molecule. All water molecule is evaporated because of increasing the temperature above 393 Kelvin. So that solid anhydrous calcium sulfate known as dead burn plaster. So what is the formula of dead burn plaster? CaSO4. This is dead burn plaster. That means removed all the water molecule from the calcium carbonate. That means from the plaster of Paris. So it called dead burn plaster. And property of this plaster of Paris, it's a remarkable property of this plaster of Paris. It can combine or test setting with water. When we mix with water in the specific amount of water, they form a plastic mass, and it is getting to a hard solid in 5 to 15 minutes. They can form the hard solid one. Okay, this is one of the property. This is one property of this plaster of Paris. And the next one is uses of plaster of Paris. Plaster of Paris is mainly using as a building industry for the construction building industries. We use this, and also using to immobilizing the affected part of organs. So if you get the bone fracture or sprain fracture, then using the plaster of Paris to stop the shaking of organs or moving the organs. Also using this plaster of Paris for the ornamental work and cast making work, cast for statues and for the bustres. The next important topic and the last most topic of this unit is biological importance of magnesium and calcium. So in the alkali metals we saw the biological importance of sodium and potassium. Here we are going to see the magnesium and calcium biological importance. Magnesium and calcium play the vital role in our biological function. So when the adult human body contains the weight about 25 gram of magnesium and 1200 gram of calcium. So this is the range of calcium and magnesium present in our body. That means the one adult human body. Magnesium plays important role in our body in the biological reaction to catalyst by the enzymes, and also reacting magnesium as a cofactor of all the enzyme which is utilized by the ATP phosphate. So phosphate which is in the ATP, and also transfer the energy. This is more essential to the stability and proper functioning of DNA, and also essential for the synthesis of DNA. And magnesium is used here for balancing the electrolytes in our body. Also, proper functioning of DNA and synthesis of DNA. When deficiency of magnesium occur in our body to resulting the neuromuscular irritation and convulsion. Deficiency of magnesium resulting neuromuscular irritation and convulsion. These are the important biological role of magnesium. Next is calcium. Calcium is a major compound in our body because it's present in bone and teeth. It also present in the blood to concentrate calcium function in our body. This calcium is present in blood, and the concentration of this calcium maintained by the concentration of calcium in blood, which is maintained by some hormones. Like hormones are calcitonin and parathyroid hormones. Parathyroid hormones. Deficiency of calcium. So deficiency of calcium in our blood will make the blood to clot longer time. So it's used here to clot the blood easily. If the calcium present in our blood in the adequate level, then that will help the blood to clot easily. and calcium play the important role in the muscle contraction. These are the biological importance of calcium and magnesium. And this much only today's class. This unit over. Thank you, students.